All right, grade 8, we are going to learn about recursive rules for sequences. And so basically recursive means that the input for the next number in the sequence will be based on the number that was previous to it. So if I give you 2, 4, 8, 16, 32, you can see that every time we go, we're multiplying this number here by 2 to get to that number. Times 2, times 2, times 2. So in order to get to our next numbers, you're going to see that we have to multiply by 2, and that'll get us the next number, 264, and then times 2 to 128. So you can see that that basically gives you the answer is by grabbing the number before and multiplying it by something. So in order to write a recursive formula, it's fairly straightforward. You're going to write what is the first term in that. So A1 equals 2. Now, to find the formula after that, you're going to go A, the number in the sequence, minus 1. So that's the previous one, right? And then you're going to write, what do you do to it? Well, we have figured out that we're multiplying by 2. 2 times your answer, number minus 1. So that's basically saying that we want to select the one before it, n minus 1, in order to find the answer to that one. Okay? The answer to the current number in the sequence. That's how I explained that wrong. So let's go through the practice set. I'm going to do it fairly quickly. Hopefully that makes sense. So for A, we have 1, 4, 16, and 64. So if you're looking at it fairly quickly, you can see that we're multiplying by 4 every time. So in order to write the recursive sequence, A1 is going to be 1. So that's fairly straightforward. What are we doing to it to find any other number from there? Well, we're multiplying it by 4a, right? So 4a, and then of course we put our n minus 1 because it's the term before it. We're grabbing this term to get to that term. So in order to get to this one, which is n, we do n minus 1. So we go to the second term. Okay, so b. Let's move on to b. Same sort of thing. We have 3, 8, 18, 8, 13, and 18. Now if you look at it, look for the pattern, you see that we're adding 5 every time. So try it on your own for a second. Hit pause, see if you can do it. Here you go. Answer is A1 equals 3. That's the first term in your sequence. To find the next term, AN, we would be doing A n minus 1 plus 3. And that would find your, oh sorry, not plus 3, come on. Must be getting later in the afternoon. Plus 5. And that would find your sequence for B. Let's go to C. It looks like my pen's a little thick. Let's try the next one here. So C would be, we have 1, 3, 9, 27. And so now what it says is, one of the terms in the following sequence is 729. Write a recursive formula that shows for the sequence and find the term that follows 729. So we're just going to write 729 here so we can remember that. So if we look at what's our first term, A1 equals 1. What's our formula? Well, it looks like we're multiplying by 3. So that should make sense so far. So if we have AN equals 3 times AN minus 1. So then how would we go about finding the next term? Right? So we're looking for the term that's after after this one. So fairly easy. So AN equals 3 times 729. So, of course, if we were to grab our calculator and do that, we go, right, what was that, 3 times 729, and we get 2187. So, our answer, AN equals, what was that number again, 2187. Okay, and now we're going to go to the next one. Which formula below generates the terms of the following sequence? So we have 2, 3, 5, 9, 17, and 33. Well, we're going to have to look at one that says A1 equals 2, because that's, you know that it's going to, the first term, sorry, that looks like a 9, but A1 equals 2. So we know we have to have that in there, so that rules out B for sure. It's not an answer. So let's try the A for a solution. So that one says AN equals 2A n minus 1. So if we grab, oh sorry, n minus 1, subtract 1. So if we grab the second term in here, right, what we got to do is go AN equals 2 times the 2 minus 1. Does that give us a 3? Yes, it does. If we want to find out the third term, that means we have to substitute the second term in. AN equals 2 times 3 minus 1. Yes, it gets us to 5. So without looking further, we know that A would be the correct answer. So that's really how the concept of recursive rules for sequences works.